Hey everyone. So in this video, I like to say a few more things about combining like terms. Specifically, I like to look at examples where there are variables with exponents. And so in math, we'll often want to simplify expressions that may contain exponents. And one way we can do this is also through combining like terms. And so we already saw how combining like terms works for expressions without any exponents in any of the variables. But now I like to look at what happens when we do have exponents in the variables. And so, we define like terms. We said like terms are any terms with identical variable factors. And so what does this mean when we have exponents included in our variables? Well, this means that the terms, they have the same variables, and they also have the same exponent on those variables. So let's take a look at a few examples of this. So let's look at negative 7x cubed. Now, what would be an example of a term that's like terms with negative 7x cubed? Well, here 8x cubed would be an example of a like term. Right, and this is really because they have the same variable as a factor, as x variable, and they have exactly the same amount of that variable factor. There are 3 x's being multiplied here in this term, and similarly here, there are 3 x's being multiplied. These are 3 factors of x in each of these terms, and nothing else in terms of other variables. And then similarly, another example of like terms might be 15y squared and y squared itself with no coefficient, or maybe a coefficient of 1 might be a little bit more precise. And again, we have the same variable of y here between these two terms, and they have the exact same exponent on that variable. An exponent of 2 telling us that they have the identical number of factors, 2 factors of that variable y. So sometimes it can be just as helpful to look at non-examples of a definition to understand it better. And so can you think of any examples that are not like terms, but still have variables in the exponents? Well, here, maybe I'll write down an example. So if I have something like 10x squared, and I have 11x. So it is true that these two terms have the same variable, this variable x, but here this one has an exponent of 2, and this one has an exponent of 1 essentially, right? When there's no exponent there, it's really implying that there's an exponent of 1. And because these two terms, they have different exponents on this variable x, these are not like terms. And so, if we think back to the previous example, the above 15y squared was really, I can view that as 15y times y. And the y squared on the right, I can view that as y times y. And so these two are like terms because really we really have the same number of factors of that variable y there. We have 2 sets of them. Whereas here, if I were to write out our expression 10x squared, if I were to just really write it all out, I'd write it as 10 times x times x. There are 2 factors of this variable x, whereas in the other term we have 11x, and there's only 1 factor. And so they don't have identical variable factors, right? So the number, or the variables are the same, but because the exponents on those variables are not the same, these are not like terms. Okay, so here these are not like terms. And then let me give you one more set of examples. Let's say 24x squared y and 13x y squared. So actually this is another non-example. And here this is because, we do have the same variables, x here and y here. But although we see the same exponents, they're not matching on the same variables, right? So here this exponent of 2 on this x variable, it doesn't match with the exponent on this x variable, which is just 1. And so right away we can say that these are not like terms, but we can also look over at the y variable and see that the exponents also don't agree there, right? 1 and 2. And so these are also not like terms. So how does this help us simplify an expression? Well, just like we were able to combine like terms when the variables didn't have exponents, we can combine like terms when they do still. And so how do we combine like terms? Well, we add the coefficients, and we keep the variables the same, and we keep the exponents the same. So this is the extra little thing to pay attention to in these kinds of examples where there are exponents, is that we keep the exponents exactly the same when we combine like terms. And so here let's look at how that works with this expression 9a squared minus 5a minus 3a plus 2a squared. And so let's say we want to simplify this expression, rewrite it as an equivalent but more concise or simpler looking expression. And so I definitely encourage you to pause the video and try this out, but I'll go ahead and continue. So in this example, maybe let's start off with the parts of this expression that we might be a little bit more comfortable with or more familiar with. So here we have two like terms that I see right away, this minus 5a and this minus 3a. And so how do we combine those like terms? Well, here, those like terms combine as, well, we just add the coefficients. And in this case, for that first term, it's minus 5a or negative 5a, right? We attach that negative sign to that term. And then the next term has minus 3a, so we also attach that negative sign. And then to combine these two like terms, we add their coefficients. That's negative 5 added with negative 3. Maybe I'll write that to the side here. So here, negative 5a plus negative 3a. Well, this is equal to, this is negative 8a. Right, negative 5 plus negative 3 is negative 8. And so here I'm just going to go ahead and write that down first, negative 8a. And then next we have these two like terms, negative 9a squared and positive 2a, right? They have the same variables, they have the same exponents. And again, we just add their coefficients, negative 9 plus 2. And so this comes out to be negative 7a squared. And so if I owe $9 and I have to, I can pay some of it off and I still owe $7. And then is there anything more left to combine? Well, here, these two terms, they're not like terms. Right, so here these are not like terms. And these can't be combined in any reasonable way to get an equivalent expression. And so we just have to leave this expression as is. This is as simple as, or as simplified as it can get. So let's take a look at another example here. And again, I encourage you to pause the video and try this out first before we do it together. So to simplify this expression, I'm just going to go through and look at all the different like terms and then try and combine them. Right, so here I have 3x cubed and I have negative or minus 5x cubed. These are like terms. They have the same variable, the same exponents on that variable. And so I add their coefficients to get, well, 3 plus negative 5 or 3 minus 5, that's negative 2. And so we add those coefficients, and then we keep the variable and we keep the exponents exactly the same. Okay, so now I'm just going to move down this expression, 7x squared. Are there any like terms with 7x squared? So unfortunately not. So we just have to leave this as is, 7x squared. It doesn't combine with anything else in this expression to form a simpler equivalent expression. We can't really do anything with it. Okay, so next up is this negative x, this minus x here. There is 10x off to the right, which is a like term with it. And so when we add these two together, negative x plus 10x gives us positive 9x. And then in this last part of the expression, we have these two constant terms, these two terms without any variables. And we can just combine these as we expect. So negative 8 or minus 8 minus 4, that makes things more negative to give us this minus 12. I owe $8, I owe 4 more, I owe $12. And so again, from here, we don't have any more like terms in our expression. All the variables, all the terms have variables with different exponents on them, and so this can't be simplified through combining like terms anymore. This is as simplified as it can be. So here in this next example, we have a part of the expression wrapped in parentheses that's being subtracted away. And so how can we deal with that part of our expression before we do anything else? Well, here I'm going to rewrite everything else first. 4t squared plus 7t. So here, we're subtracting away that group in parentheses, so that means subtract away. Well, let me ask you first, actually. What belongs next? What belongs here next? Well, here, if I'm going to subtract away that group, I'm going to subtract away that 3t squared. And then that minus 5t in the parentheses, well, I'm subtracting that as well. And so this is going to come out to plus 5t. And now we're really ready to combine the like terms. Really, everything's a little bit more free-floating, and we can just look at each term and compare with its like terms. So 4t squared, it's like terms with this minus 3t. And combining these like terms, well, we subtract the coefficients, so that's just 1, and we can omit the 1. Maybe I'll write it down for now. 1 t squared, or keep the variables the same. We're really just counting how many copies of that t squared we have, and if I have 4 of them in the first term and I'm taking away 3 of them, well, now I only have 1 copy of that term t squared. And then next, the 7t combines with the 5t. These are like terms to, well, 7 plus 5, that's 12t. And then they're not like terms, I can't do anything more with this, but I can rewrite this without this 1 here. I can just rewrite it as t squared plus 12t. Right? These two terms are really the same. And so the last example I'd like to go over is this one here that maybe looks a little bit messier. And so if you're filling up for it, please feel free to try it before we do it together. So here, I'm just going to rewrite this expression without the parentheses. So I've got 5ab squared minus 3ab. So here, if I'm going to account for this negative, or minus this negative 2a squared b, well, that's really the same as plus 2a squared b. Right, and then here I'm going to add on this group here. And if I'm going to add on that group, well, it's really the same. Those parentheses aren't really telling us anything new. I can drop those parentheses. And adding on negative ab, well, that's really the same as subtracting away. Maybe I'll write it, I'll write it like this. Subtracting away ab, and then also subtracting away ab squared. And now we can just combine the like terms. And so which terms are like terms? So 5ab squared, what is this like terms with? Well, it's like terms with the last term at the end here, right? And I'm going to make sure I'm going to underline that subtraction sign. And so this gives us, if we combine these two terms, I have 5 sets of ab squared. I'm subtracting away 1 set. Well, it's giving me 4 copies of ab squared. And then next I have minus 3ab and minus ab. Combining these two like terms, I'm taking away 3 sets of ab, taking away another set. I'm really taking away 4 sets of ab. And then this last term isn't like terms with anything. This is plus 2a squared b. Right, so like we said earlier, we do see the same variables here, we see the same exponents, but the exponents aren't quite matching up in the right way. Right? In one, I have only one copy of A, the other, I have two copies of A being multiplied. These don't have identical factors, identical variable factors, they're not like terms. And so this is as simplified as it can be. This is the final result for this problem.